so we are solving this system of equations. Anytime you have two or more equations, that's a system of equations, and we can use substitution or elimination. So I have a y and a negative y. I've got an x squared. So I want to get rid of the y's. So how about if I add x squared to both sides and add 4x to both sides, and those go away, and I get y equals, and I'm always going to write it with the highest exponent first. All right, so that's in standard form for my quadratic. And then now over here, I'm going to add 160 to both sides. And then I have this negative y by itself. I have 18x squared plus 110x plus 160. And now these look really different, right? But they're equal. So I can add them to both sides. All right. And when I do that, I combine these like terms and I get 0 on the left-hand side. And over here, that's a 1, so I have 19x squared plus 114x plus 171. And that's a ridiculous high coefficient, so I want it to go away. I'm going to check and see if there's a greatest common factor. So I'm going to go to my calculator here. I'm going to do math, num 9, and I'm going to put in 19, comma, 114. And 19 is the greatest common factor, so I can divide both of those by 19. How about 171? Can I divide out 19 from that? Yes. Okay, so I'm going to divide all of these by 19. So we get 0 equals, and then the 19 comes in front, right? The GCF always goes in front. And I'm doing the undistributed property, so I'm dividing. I get x squared plus, and then this would be 6x plus, and you just divide this out and get 9. Okay? And then now I have 0 equals 19. And I'm going to factor this. I've got a perfect square, so that's x times x, and a perfect square, 9, 3 times 3. They're both positive, so that's both positive, and 3 plus 3 is 6. So to solve this, I've got x plus 3 equals 0. All right, so that means x equals negative 3 is my solution there for x. So I go back up to my original equations. I'm going to substitute x equals negative 3. All right, and I can figure out why. I would want to go to my original equation, but I don't really have a nice one like that, so I'm going to go ahead to that y equals. I'm going to go y equals, and I'll plug in x squared plus 4x plus 11. All right, and if I go to my table, got big numbers there. I'm going to look for the value where x equals negative 3. And x equals negative 3. If x is negative 3, y is 8. Okay, or you might just substitute that in. So that is my solution. X equals negative 3, and y equals 8. And remember, this was a double root. So those are my two solutions. I have two quadratics, so I have one going up, right, and one going down. And then they would intersect in this one spot. I only have one solution there.